Welcome to Quality Branding Hub. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today, also, I'm going to discuss about a very important topic that is in the construction, the RCC. In the RCC, we are using the reinforcement steel, but the shape of the reinforcement steel is always circular. Why circular? Why not other shape? Maybe the rectangular one, maybe the square one we can use, but not. We are using the circular diameter of the steel. What is the reason behind it? Yes, there is a reason. So today's video, I will discuss each and everything that why the reinforcement steel is always circular in the construction or in the concrete. So stay tuned until the end to get the full information. New in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you'll get immediate notification. So today's topics is why is steel in concrete always circular. Now we all know that the concrete is the main pillar of the construction. So in any modern project, we cannot even think without the concrete. And now in the concrete is not only the plain concrete, is the RCC or the reinforced cement concrete. That means we need to introduce or need to place a reinforcement bar inside the concrete in order to get the durability or the structural stability. Now the size or the shape of the steel is always circular. Why this circular shape of steel is used in the concrete? So there are several different reasons. The first reason is the uniform stress distribution, then better bonding with concrete, fatigue resistance, torsional strength, ease of manufacturing and handling and installation. The first is uniform stress distribution. Why? See, why we are introducing steel inside the concrete? That means the concrete is very much weak in the tensile but very much strong in the compression. But in any structure, not only the compression or not only the tensile stress is generating, but in combination the compression and tensile both are generating in any structure. So in any structure, if we are using only concrete, it will break. So in order to rest or instead for the tensile state, we use the reinforcement bar. So now the distribution of load need to be very uniform, because the tensile stress which is carrying by the reinforcement, that should be very much uniform. So the circular cross section distribution tensile and compression stress evenly around the surface. See here you can see the picture. In this picture you can see the circular bar. Whenever load is coming, it is from, let me zoom it. See, in this picture, you can see that whenever load is coming, its load is evenly distributed throughout the surface. Now, here is also load is distributed, but the center, from the center point here, the distribution point here. So what is the center point of the circular, this rectangle here? From this point to this point and this point to point, the length is different. So the load distribution will be the difference. But here it is coming from the center of the circle. Each and every point of the circumference is the same. So that is why the load distribution will be the same. But here you can see from here the corner point is the more distance, but the center point is the less distance. So there will be the uneven stress distribution if we are using any other type of steel. But in the circular one, it's the uniform load distribution. So why it is important uniform load distribution? Because it's any structure, whenever the load is coming, that it is need to be distributed throughout the section. Otherwise the one section will be higher, more load, and another section will be the less load. So that is not the structural stability or the structural uniformity. So for that we need to do the uniform stress distribution, and for that is why the circular bar is more preferable, because a circular cross section distributed tensile and compression strengths evenly around each surface. And if the bar had corners like square or rectangular, here you can see here, the stress concentration would happen at the corner, leading to cracks and premature failure. Because here's the from the center point, the distance from the center point, the corner portion distance is more, the load will be the more, so there will be a cracks and premature failure. But on the other hand, the circular, there is no corner, so every point there is a load distribution is the same, so there will be no cracks and the premature failure. And round bar, there are no sharp corners, so stress flow smoothly. So what is our intention? To distribute the tensile stress evenly throughout the section, and for that the circular bar, for its shape, that's circular, so it is, there's no corner, and from the center of gravity, the every corner distance is same, so it is distributed load throughout the section evenly. So that is the main point, that its uniform stress distribution is the main point for the circular bar. The next is better bonding with the concrete. Now, why? The concrete grips steel via mechanical interlock and adhesion. So in the steel bar, we are making the ribs, that I call the ribs bar. So in these ribs, that's a grip is become the way more stronger than any other shape. Then circular bars, especially different bars with ribs, provide uniform bonding all around. And then if the bar were flat or square, bonding would be weaker on flat surface and uneven. So if the surface is flat or the surface is the rectangular one, the center of gravity is not the same, and if the center of gravity is not the same, what will happen? The load distribution will not be the equal. So that is why what will happen? See here in the circular square bar, what is saying, if the bar flat or square, bonding would be weaker. See, there is a corner, in the corner there is a problem for the bonding, see, in case of circular or the square. But in the circular, sorry, if in the square or the rectangular bar, in the corner portion there will be a problem for the bonding, but the circular, it's throughout the same, the bonding will be the proper. So better bonding with concrete is also one of the criteria to select the bar in a round shape, not in circular or the rectangular shape. Then the fatigue resistance. Now the what is fatigue is the repeated load on the structure. Suppose in the road the vehicle is moving, so repeatedly the load is coming on the surface, on the structure, so that is the fatigue can be generated. So this bar or the circular bar is the better fatigue resistant. The circular sections are better at resisting fatigue, repeated loading and unloading, because stress are evenly spread. See, so already given the example for the road, that repeated loading, unloading, or repeated load is coming. So that is why it is very much important that the load will be, or the stress what is generating due to the load should be evenly spread, and the round bar is the number one for that. Sharp corners in other shapes would become points of fatigue cracks. See, not only for the stress distribution, but also for the fatigue resistance also in the corner, that will be break, because from the center of gravity, from the bar, the corner is the more, distance is the more, so there will be distribution, load will be the more, and there can be crack. So what is this? Uniform stress distribution, better bonding with the concrete, fatigue resistance, these are the main thing for the bar become the circular one. And the next is coming the torsional strength. Now in any structure, not only the tension, not only the compression, but also the torsional stress, also torsional stress also generating. So in order to get the structural stability, we need to resist the torsional strength also. So the circular bar resists twisting or torsion much better than any other shape. In real world condition, earthquake, vibration, torsional forces can develop, circular bars perform better. So if there is any twisting in any structure, like a earthquake, whenever it is happening, so the circular bar has edge over the others, because it has the more in the shape, it is given the more torsional strength in the structure. Then it is coming ease of manufacturing. Now we need to manufacture the steel as per our the requirement. It is easy to manufacture the round shape steel bar than the any other shape steel. It is easier and cheaper to manufacture steel bars in rolling mill in circular shape. Rolling and extrusion process naturally produce round bars and more efficiently, and then producing complex shapes would increase cost and manufacturing difficulty. So these are also another point for selecting the circular bar in RCC. Then handling and installation. Circular bars are easier to bend, cut and tie. Now it is another point that the circular bars we need to bend according to our requirement. That is not in the RCC, not only the straight bar we are using, but we need to bend the bar at the end to develop the development length and the anchorage length. So the circular bars are easier to bend and for the any other shape and easy to tie. So that is why the circular bar are using. And bending round bars for hooks, bends and sit-ups are uniform and predictable. Otherwise, if it is circular or the square or the rectangle bar, it can break whenever we are doing the bending. And the square or angular bars would be harder to bend without damaging them, because without the bend it is not possible to do the RCC work. We need to bend as per our requirement, and for that also the round bar has the benefit for with any others. And also other whenever the development length we are providing, that this stress whenever from the steel to concrete and concrete to steel whenever it is transferring, that also this circular bar has the better performance than any other square or the rectangular bar. And so that is why we are always using the circular bar. So what is for uniform stress distribution, better bonding with the concrete, fatigue resistance, torsional strength, ease of manufacturing, handling and installation, and also for the load distribution from concrete to steel and steel to concrete. And that is why we are using the steel bar always in the concrete. And I hope you find it useful, and if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video you will get immediate notification. So I'm waiting for your valuable comments, so that from your valuable comment everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.